Just give me a moment to do some little nitty-gritty and then okay. And hi Gagan, hi Anil. So I believe everyone is able to see my slide, right? Mahesh, are you able to see the slide?
Yes, I can. Yeah.
Okay, cool. Yeah, good. Yeah, just 1 minute and then we'll start. We'll make it live also. Like there's a parallel streaming going on different Facebook and other channels. So we'll see if things are going on well there, and then we'll start fast. Just give me a moment. Yes. So yeah. Okay. So I think we should start. Uh, So hello everybody, this is Anjani Kumar, your host, and as you know, we have been hosting these sessions for almost 3-4 months, and a lot of we have been covering on a lot of different topics. Regardless of it's not just technology; it's more around the holistic view of technology and more around cloud, and that's where the whole platform comes up as multi-cloud for you. So today, I'm pretty much excited to share you on a share you about uh, a niche topic in the market in the industry, and which is around zero trust. Zero trust is something which is quite hard because you will need to understand around the way technology has moved up, the way technology has explored itself, way technology has experimented itself, upgraded itself, and the way now it has been massive. There are hundred of touch points. Touch point is like where the connectivity is from where your customer and user comes to. So you will have to understand that whatever you build is like your home as a software, and you will never want someone to come into your home if you don't know him. So it's something is based on that, and obviously Mahesh is going to tell a lot about it. But starting from it, so you know a single statement says everything is a single vulnerability is all an attacker's need. There is a single point of a failure, or there is a single hole loophole, and it's all an attacker need, and attacker will be able to attack your system and then do whatever. So this session is part of our commitment to the community with our years of experience that we have spent in the industry, that we have won from the industry, and now it's a time to give it back to the industry and the people of the next generation, and even our colleagues and co-mates who are exploring themselves in terms of multi-cloud. So this is our enterprise cloud learning series. Probably this is the first one on extreme engineering, and we promise we'll keep multiple session on it, and on the topic of extreme engineering. And one of the part of it, and very most important part of it is security. And security is extreme importance, and security is something which anyone cannot just forget about, just cannot leave it. But how to implement security correctly is all when you talk about, and when we start thinking around zero trust is. So uh, so the agenda I see is Mahesh will be talking on extreme engineering, especially on cloud security, monitoring and governance using multi-cloud, implementing security on public, hybrid, and in-premises cloud, DevOps strategy, and moreover, at the top of it, Mahesh will give you a scenario around how this security get implemented correctly and why it's a need. What are the issues that can come up in a big system if you don't implement it correctly. So uh, about Mahesh Patil, we know him from long. He's a star technology solution architect. He's a star researcher. In terms of the biggest thing about Mahesh Patil is that if he pick up things in a specific manner, if like a researcher, he do a long-term research on that topic, and experiment it live with the clients, and with the real-term implementation scenarios, and then only he talk on those topics. So zero trust is something which Mahesh has been dealing and working and researching on it for the past couple of years, and today we'll be going to hear from him directly. He has been part of Publicis and Cognizant, and he is a real leader, mentor. Wherever he has gone, he has a lot of respect from people, an enabler and blocker. He's a director technology at Publicis Sapient, and this is his LinkedIn profile. You can directly connect to him anytime if you have any issues or any questions related regarding this topic. I'm your host. I am the founder of Multi-Cloud for You. I'm inventor, leader, mentor, enabler. I am ex-Publicis, RBS, Microsoft, and work with government, NGOs, research organization. I have almost double decade of experience. I'm an entrepreneur too. And I'm a principal architect of Multi-Cloud for You. This is my LinkedIn profile. You can come connect to me anytime. So now Saul, so where can you watch our session? Is all about, you can go to the multicloudforyou.com, create your account, and if you have any issues, you can go to help and FAQ page. It's always there on the home page of the site. Any page you can connect, and then you can find out more about it. So how do you watch our session? You can scan this, and this again, I would say this is again the session on extreme engineering. So they've also turned down this QR code, but if you scan it, it will work. So it will directly take you to the subscribe page. Uh, why are we doing this session? Why are we doing this session? I've already said about that. These sessions are more about giving back to the community, and that's a major important thing and major important part of this session. Are a lot of technologies, experimental scientists, and from academia and industry come together and talk about on different praising topics, and that's how you get acknowledged with this topic and go back into the project and implement it. And also we talk on the basic topics too, and that the session keeps on happening. So back to Mahesh, and I'm really feeling proud to have him here. Mahesh, it's all yours. We are not able to hear you, Mahesh. Uh, uh, can you check your mic? Yes. So
Yeah,
Mahesh, can
I'm here.
yeah,
Can you
yeah,
hear
yeah,
me?
yeah, yeah, yeah. I
Yeah,
can hear you
cool.
now. Yeah, cool.
Just checking, which screen are you able to see? Are you seeing the
This one,
single slide?
Tesla. Yeah, Tesla uses code too. This is a
Okay.
single slide. Yeah,
Okay, single slide, right? Okay, because I
yeah,
have dual monitors, so I want to make sure I'm projecting the right screen.
yeah.
Um, Hello everyone. I mean, thanks Anjani for the long intro. But I think we've got global folks from various places here. So good evening, good morning, and good afternoon, depending on where you are. I'm here in the UK. It's a sunny day out here, and I'm going to start with um, a person who's famous for his tweets, right? And I believe most of you must have seen Friday where I think the Tesla stock actually crashed 10% because of another tweet from Elon Musk. And this wasn't the first time, right? Uh, but I want to show you this tweet from back in August 2019. And this was just prior to the Hurricane Dorian in Florida. And some couple of customers had asked whether they would enable supercharging and extra battery life on some of their cars. And as you know, most of their cars run on code and automation, right? And they're actually enabled within a short time. They're actually enabled these features across the cars affected area, and all of this was done remotely. Now, Tesla can do that because obviously they use code heavily and automation heavily. But how about someone who is not as modern as Tesla, for example? This is the Ford 150 pickup truck. I haven't driven any it ever. I don't really fancy trucks myself. I am sure some of the friends in the US probably might fancy it. But this truck actually runs on 150 million lines of code, and I think that's probably a couple of years ago. Those numbers are from a few years ago, so I'm not even sure how big the current code base is. But if you look at the industry average, I think that would probably mean about 2.25 million bugs just waiting to be discovered or stumbled upon, either for an attacker or for a user. I hear someone raising a hand. Is there a question,
Um, Ideally,
Nishant?
yeah. So ideally, we take the questions at the end of the session, but no issues. You can take
Okay.
middle. Yeah.
Okay, cool. All right. Maybe
So
that was just an error. Sorry. That's okay.
yeah.
I'll
No, no.
continue.
Yeah.
Cool. So that's cars and trucks, right? But how about something else, something different? Well, if you looked at, I'm not sure if you've seen this story before, but this is actually a Samsung refrigerator which was in a John Lewis store here in the UK, and it's showing a certificate error. Well, all of these things, what they're pointing to is a simple fact: the fact that code is everywhere. Everything runs on code, and it's in things that we do not even imagine. I mean, these days, honestly, I think there's so many tools and technologies we use, especially in these interesting times where technology. I mean, people can't even go outside, so everyone's relying on remote communication, and things like Zoom, WebEx are pretty commonly being used across the globe. Um, Interestingly, about Zoom itself, I don't know if you've seen, if you heard of this, but there's been a lot of security issues that have been identified over a long time, and I think they've started to act on them. In fact, there was a recent story from the Ministry of Defense here in the UK, where they wanted to stop the use of Zoom because of the inherent security issues. When you have some time, you can look at the link at the bottom here later on, which basically opens Zoom's interface without even going to their website, actually. So there's some interesting issues out there, and I'm sure you can do some research at the end of it when you have some time. But Zoom isn't the only one, right? Even powerful countries like China are facing the brunt, especially because in these times. Um, there was a recent article about Vietnam being alleged of trying to hack into some of the Chinese organizations to gain insight into the COVID response of China. And obviously, China is pretty modern and advanced country, so it's interesting to see countries like Vietnam trying to hack into their systems or organizations. Um, but it's not just the web-based interfaces, or it's not just the countries that are being attacked, but also there is tools like VMware's vCenter. I mean, if you worked in the virtualization industry for long enough, I'm sure you know vCenter is probably one of the most commonly used tools across the industry for virtualization. And there was actually just recent, this is pretty recent, a CVSS 10 score vulnerability. And for people who do not know what CVSS means, it's a vulnerability system scoring system. It goes the minimum number. It ranks from ranges from 1 to 10, 10 being the highest. So this was a recent vulnerability that came up, and what it allows someone to do is basically gain admin access to the vCenter interface, which basically would mean they can abuse it and do things they shouldn't be authorized to. Now, I think with all of that background, I mean, it's obvious, right? All this is pointing to a simple fact. And don't take my word for it. If you know the gentleman in this picture, this is Ken Thompson. He's one of the famous personalities. He was man behind Unix programming, Unix language, Unix operating system, and also he worked with Dennis Ritchie for in building the C programming language. He's published this paper. I think it's probably in early 90s or something. He used to work for Bell Labs back then. It's called Reflections of Trusting Trust, and I definitely encourage all of you to go back and read this paper. It's a pretty short read. It's not long enough. You can read it in probably 15-20 minutes. But in the paper, he describes how he could have made a small change in the C programming language that would then allow him to log into every Unix terminal across the world. And I think he summarized it really well. He says basically, you can't trust code that you did not create yourself. In today's times where everything's running on code, I think that's a very powerful message. Everything obviously is running on code, right? You have IoT devices, you have cars, driverless cars. I mean, even if they are not driverless, they're still running on code, some form of code, as I just talked about. And then you're at your home using home automation systems. I mean, everything is obviously running on some form of some shape or form is running on code. And if you can't really trust the code inherently, obviously you need to take some extreme measures to ensure your application and users are secure. But that's not the only reason. It's not just the fact that you cannot trust the code. There has also been a big shift in terms of technology architecture and applications. If you look at traditional applications, right, traditional architecture, I'm sure most of you must have seen some form of this. I think this is probably an architecture that existed a few decades ago, where every organization had a internal network where they used to host all their applications, enterprise applications, or anything they wanted to expose outside. And before exposing it, they created this notion of a perimeter network between two sort of firewalls, and anything inside the internal network was trusted, so it can talk to each other without any authentication, without any transport level security, because it was considered trusted network. So it was sort of the trusted network and the untrusted network at a high level, and then the consumers had to come through a firewall via this perimeter network, which had some sort of reverse proxies or web servers that would then expose applications that were internally hosted. But in today's world, technology is quite complex, right? And with two technologies like Kubernetes, especially, which allows you to run workloads across hundreds, if not thousands, and honestly, thousands of virtual machines. Then you have distributed databases, also similarly, right? Pretty infinitely scalable, something like Cassandra, essentially, or distributed messaging systems like Kafka. They're all very complex technologies inherently, and the counts are staggering. I mean, in some of my recent programs that I have been in, I mean, we have estimated at least hundreds, if not thousands, of containers and applications running on this landscape. And so technology has changed a lot as well. And basically, what that means is with this scale and with the change in technology landscape, you need a different approach towards implementing security. And that's exactly what I'm going to talk through in the rest of my talk here. It's about this shift in mindset when you're applying basic principles when implementing application software or developing software, building infrastructure as well on the cloud. And honestly, you can apply this even if you're not on the cloud, private cloud, on-prem. I think the same principles are probably pretty applicable. Now, in terms of the actual framework, it's obvious since code is what you sort of create all the time. It's obvious that you should start with securing your code, right? And when you talk about code, it's how you write the code as well as how you build and deploy the code. The goal being you need to ensure that whatever you build is exactly what is deployed in your live or production environments. Now, on the screen, you're probably seeing a CI/CD pipeline. I'm sure most of us are probably familiar these days with the notion of an automated code deployment pipeline and continuous integration pipeline. But it's important not just to create an automated pipeline, but also include some key security measures in it. So starting with application development in the coding phase, use most of your developers, engineers are writing code constantly, and they use some form of IDE. As part of that IDE, it is important to recognize that a lot of these IDEs come with plugins that allow you to look at the security of your code, to ensure the libraries that you're using are still current, or if there's any vulnerabilities or issues in them, it points out to them immediately so they can keep it up to date. So use software composition analysis plugins, and then tools like Veracode and Fortify and others to scan the code as it's being written by the developers. On top of that, you should implement signing commits. So anytime someone commits your code, you know that it is that developer who sort of committed it. It sort of validates the identity. But also ensure that there is some sort of form of peer reviews in today's world, especially because not everything can be caught by the tool, and also sometimes people can ignore what the tool suggests, and it's always good to have something being reviewed by a separate individual who also looks at it from a different perspective and identifying issues before they get into the mainstream. In the build phase, obviously integrate the testing tools, but also definitely try and ensure that there is some sort of static application security testing integrated as well. This is where people use tools like Veracode again and SonarQube to look at the quality of the code. In the signing and testing, obviously, aside from the functional performance tests, it's also important that the artifacts you generate are signed so that when you deploy to production, you can actually validate them as to coming from a legitimate source, but also running dynamic security testing, vulnerability scanning again of the artifacts and its dependencies that it brings. And all of this is again to ensure that whatever product you're deploying at the end into your production space is actually authentic, coming from an authentic source and exactly what you wanted to go there. And even in your deployment environment, obviously, there is certain tools I'll talk about later on to look at runtime vulnerability scans as well. But why is this important? Well, if you've followed the British Airways breach that happened, I think a couple of years ago, there was obviously stolen information. But the way this occurred was on their website. They were using a modernized JavaScript, and somehow an attacker was able to introduce a malicious script in there, which basically captured data from the website but pushed it to a third-party site. And I think this is probably in today's world, especially when I think the online and digital media are so overutilized, especially in the past few months. I think it starts to become really important, especially when you're building web applications and interfaces for your consumers. You need to ensure that you have full control of over the code that is getting into your production, and you know it's coming from authentic sources. No, it doesn't have vulnerabilities and issues that I'll talk about later on. And that goes back to the whole securing the code and the pipeline and the same measures I talked about. So great. So we've talked about securing the code. The next logical step is to start looking at identity. And with respect to identity, I want to talk about this recent assessment of the Kubernetes project. I think I'm sure almost everyone here knows about Kubernetes. If you're a technologist, I'm sure at least you've heard of it. It's a platform that's probably widely used across the globe. It's my favorite platform, I think, since long, since it came out back in 2003. But in last year, in August, there was a review done by an independent company of the Kubernetes code base. And I would say, honestly, it's one of the pretty robust code bases of all the other products out there that are available as an open source solution. But they found around 37 vulnerabilities, of which there were 5 high vulnerabilities. I mean, to put it into perspective, I personally don't think for a project of that scale, it's a huge issue per se. But one of the vulnerabilities were actually the fact that there was no authentication on certain flows, and specifically the API server and the kubelet is the example that was taken there in certain versions, that version of Kubernetes. What that means is someone could create a kubelet and register with the API server and get access to some of the metadata that the API server provides them. Now, for a platform that is trusted globally and used globally at that scale, I think this can be quite a scary equation. Um, so how do you prevent that, right? How do you protect from that? I spoke about strong identity, but it's not just strong identity of end users. So me as a administrator, when I'm accessing Kubernetes, that's one level of access, right? Obviously, customers accessing the applications, that's another level of access, which also requires a strong identity foundation. But there's also application to application communication, and then devices as well. What devices you're using to access your cloud platforms also start to become relevant. And you need to start applying these stronger identity principles across all of them. Now, the good news is most of the cloud providers some offer some capability in each of these, and I mean, as a result, I mean, a lot of it is table stakes. But I'm sure you're familiar with single sign-on, so ensuring that all your systems that your administrators slash users are using require a single username and password versus trying to use disparate systems. It just complicates the security position. But on top of that, it's important to use multi-factor authentication for anything that's privileged. And again, if you look at GCP, AWS, and Azure, they all provide this out-of-the-box capability where you can enforce MFA for certain privileges, certain access, or all the time. Mutual authentication is a technique that is used for application to application communication as well. But at the same time, short-lived credentials is also important. I mean, especially when you provide performing some, if you're an administrator who's performing certain operations on, say, using AWS CLI or the Azure CLI, it's important to enforce some sort of short-lived credentials, short-lived credentials, so the credentials expire. If you're using something like AWS SSO, single sign-on capability, which allows you to log in to the interface and then generate credentials at runtime, they can expire, and you can configure the expiration of that. And that's what I mean by short-lived credentials, so that you don't store the credentials for long enough. And then there's technologies like Vault, which just allow you to scale that up to many different applications and many different users. A list privilege access is obviously something that's basic. So honestly, it just means that provide the access only that is required for the duration that is required. Um, there's another reason why this is important, and that's that there was another research done by Stanford University a few years ago. What that revealed, they looked at IoT devices, about I think millions, 83 million devices across the globe, and they looked at various households. So they looked at things like switches and routers that people use in their homes, as well as that are used by providers as well. What they identified is almost 88% had FTP, weak FTP credentials. So wherever FTP was in use, the credentials were honestly, it was admin, which means any hacker or someone, an intruder who's trying to get access, could easily just gain access to the FTP server running on that particular device. And similarly, there were telnet credentials, also admin on 35% of them. I think this is quite scary in terms of where we are, especially because of the adoption of the digital channel as well. Now, having said that, I'm sure most people change the default credentials, right? But what if they are not changed? I'm sure some of us probably just connect the router when it comes from the provider and just not even bother changing the username and password of that. But that would mean that someone, an attacker, can gain access to it if because you had not changed the credentials. The same study also highlighted the fact that 93% of the routers that they looked at had an HTTP administration interface on port 80, which meant no transport level security. That means someone can intercept your calls and actually get access to the data that you're exchanging. And I guess in terms of looking at traffic flows across that you have to navigate today when you're accessing cloud services, I think this starts to become scary. If you look at a typical application that's hosted on the cloud nowadays, right? You have the end user or an administrator whose goes via some sort of a load balancer, and from the load balancer, they are trying to access applications that are hosted on an automatically scaled environment, virtual machines. It could be Kubernetes-based applications and such. And these applications further access databases, S3 buckets, whatever else that is hosted within the VPC. I've highlighted certain areas where it's important to try and enforce some controls on the traffic between various entities, and that's where it's important to ensure that you secure the traffic and the network flows. Now, there's 4 or 5 simple measures when it comes to securing the traffic. I mean, the most very basic one is transport level security. I think I've talked about it so many times already, but it's basically ensuring that the two parties who are trying to talk to each other encrypt any data that is being exchanged between them. And most of the times, I mean, HTTP has a HTTP S as the protocol, which is the transport level security, and similarly, most other protocols have some form of encryption where they exchange only encrypted data. What this means is that there's a man in a this there's no man in the middle attack who someone who can gain access to this data because it's always encrypted. But that's itself is not sufficient. It's also important to ensure that you use the latest versions of the protocols and ciphers. So TLS is great, but you should be using the latest version of TLS. 1.2 is the most latest that is globally used. 1.3 is out already. In fact, Netflix is, I think their CTO just announced that they would probably be moving on to TLS 1.3 or are moving to 1.3 already. But at the same time, underneath that, it uses different protocols and ciphers, and you need to ensure that only the latest and greatest protocols that are supported and ciphers that are supported are in use. Um, Beyond that, there is firewalls. There's layer 3 firewalls, and which is things like security group, and then there's layer 7 firewalls, like the web application firewall, which AWS provides out of the box. You can also buy appliances which specialize in the WAF technology, which also should be used as well. If you're using something like Kubernetes, it also provides a network policies as an additional measure. But at the same time, there's technologies like service mesh, which basically simplify this and allow you to scale it up to hundreds and thousands of applications that I was talking about earlier. And that the service mesh and the service meshes like Console, Istio, Linkerd, and many others, they provide capabilities that allow you to control that
एक गिलास
east-west
दूध देना
communication across your applications.
है, आधा गिलास दूध
So
देना,
absolutely secure your traffic flows, and use all
आधा
of
गिलास दूध.
at least a few of these to ensure that there is sufficient controls in place when you start to look at your cloud-based infrastructure. So great. So you've secured the code. We looked at securing the identity and using a secure identity foundation, and then we've looked at traffic flows. The next obvious step is to look at data. And a classic example when it comes to data is the Marriott data breach. Uh, the Marriott data breach that happened back in 2018 was basically, as part of that, some of the PII data was stolen. Now, a lot of it was actually encrypted, which is good news, which means it's not easy to decrypt that information. But also, the attackers were able to gain access to some other keys as well, so they might be able to unencrypt the data. But at the same time, I think the biggest problem there was there were at least there were many unencrypted passport numbers as well that were stolen as part of this. I think this is pretty important when it comes to systems that we build, especially applications that are capturing personally identifiable information or payment information from end users. And some of this, obviously, controls are pretty important when it comes to PCI compliance and things like that. But obviously, protecting the data, which is probably the most important thing today, especially because we all have our digital identities. We are all interacting with various channels online. It's pretty critical to ensure that softwares we build protect the data. So how do you do that? Well, I've talked about the basic traffic transport level security authentication already, so I won't repeat some of those the items in gray. But when you look at your application, there's actually three layers where this data protection becomes critical and controls associated with that. So I'm just going to start with the database itself. So most of the times you're using some sort of database, Cassandra, MongoDB, AWS has DynamoDB, or whatever else you may be running, or a relational database for that matter. It is important that you encrypt data at rest, which means it's not just, and when I say encryption of rest, it is not just the OS based, the default encryption of the volumes that you do, but also database encryption as well. A lot of the databases provide integrations with systems like Vault and then key management systems to encrypt the data they store, or the files that they create. This provides that additional protection from an administrator who gets access to the virtual machine to be able to copy the data and decrypt it in any way. And as I said previously, from the Marriott data breach, it's also important to ensure that you also keep stores those keys securely in a different system externally from the database, so that they are not also if someone gets access to those file system to the files, they don't get access to the keys as well at the same time. So encryption of data at rest at the database level, not just the OS level, is definitely something very important. Then you have the application to the database communication, absolutely TLS, transport level security, and using a strong identity foundation there to ensure that only the application has access to the data that it needs to, and nothing beyond what it needs to, so that if someone were to get access to the application itself, they can't get access to the data. And then finally, there is, for something like passport numbers or card numbers, you need to also use this additional level of protection, and that is field level encryption. And I think this is an interesting emerging feature that has come up with a lot of databases nowadays. I think most of them do it. Most of the NoSQL as well as SQL databases do that. So what this is basically, if you have something very confidential or very important as part of the data that you're storing in a table, you can encrypt that on top of, in addition to the encryption at rest. So a column in a SQL server, or a field in your JSON, that your object that you're storing, or any other database, and you do that field level encryption. What that means is also when your application reads it, it is by default encrypted, and the application has to go out and get the key to decrypt that information. There are obviously performance penalties and things like that you need to consider, but obviously it's the right approach to build the right security for the right kinds of data. You obviously don't have to do it for everything, but at least for the sensitive data, it's highly recommended that you put that in place. So great. So now we have looked at securing the data itself, the data that your applications generate, the data that is stored in your databases. The next thing I would love to talk about is um, slowly transition into what is called the vulnerability management space. And last year's Capital One data breach, I think, is a classic example of that. So obviously, I'm one of the affected users. I've been a Capital One customer for many years, actually. But as part of this breach, there was an ex AWS employee who actually used what is called as a cross-site request forgery technique to gain access to some of the S3 buckets that was holding some of the customer data. And the way she did this was she could do this was because the firewall that Capital One was using had a misconfiguration / vulnerability. So she could get past the firewall, gain access to some compute capacity within the AWS ecosystem, and from there was able to access generate credentials that could allow her to get access to S3 buckets and download loads of data. Um, this now misconfiguration is just one type of vulnerability, right? And there are many other types of vulnerabilities, and hence what you need is an automated vulnerability management solution that looks across to identify different types of vulnerabilities. I mentioned in the code phase that obviously the libraries you use, the code that you write may also have inherent vulnerabilities, and it may be the version of the software you're using. So you need systems that provide you that constant feedback on what, if anything has become vulnerable. Things like, for example, the vCenter vSphere, VMware vCenter product that has now the CVSS 10 vulnerability as well. You need something that reports to you when something like that comes up, so you can immediately react to it, apply an update or a patch to it. And in addition to just the vulnerabilities in software, you also have things like, as I said, misconfigurations. So someone, let's say, had an object database that has been left wide open, a protocol or a port and or that is left open to over the internet to everyone, right? So things like that, or you have buckets, S3 buckets or object stores that are publicly accessible. That also is part of a misconfiguration. Someone may have done it inadvertently, not knowing that outside users are able to access this without, say, any form of authentication. And then there is other things like malwares and insider threats, outside threats, various kinds of vulnerabilities across various systems. And the tools that allow you to navigate, identify those, obviously, there's cloud providers provide their own standard tool set. So AWS has Inspector, Guard Duty. They also now have a security hub that allows you to consolidate all of this information. And then similarly, Azure has Sentinel Security Center. Google has its own security center. But then you can combine that with tools like Twistlock, which and Aquasec has many other tools as well that look at your application estate and look at vulnerabilities within, say, Kubernetes-based applications, looking at role configurations, looking at application configuration, looking at the network policies, the network communications, and things like that. But the whole idea behind all of this is to identify any form of vulnerability or misconfiguration in your infrastructure or an application, so that you can then either automatically resolve it, automatically patch it. So let's say a product becomes vulnerable, like the vCenter one. You should have an automated patching for most of your software so that it can automatically take the latest fix and apply it, upgrades, as well as also identify any vulnerabilities. So if it's a code level thing, for example, if there's a library, Apache logging or Apache Commons that becomes vulnerable, you should have the process to sort of resolve that vulnerability through your CI/CD pipeline. And then runtime vulnerability scanning is what is offered by tools like Twistlock. So again, at the end of the day, what you want is to identify something that allows you, or a capability that allows you to look across your estate and identify vulnerabilities and resolve them as quickly as possible. Everything I've talked about so far, the whole framework, basically generates a lot of data and it's generating a lot of insights, right? Um, but how do you act on it in a simplistic manner? I think going back to my car analogy, because I think I started with the cars since the beginning. I spoke about Tesla and Ford. I also wanted to talk about the dashboard of a car, right? So a car probably has, I think, hundreds of sensors probably that provide, I mean, modern cars, obviously, but they sort of expose this in a simplistic manner, right? The dashboard, again, this is a dashboard from an older car, but even newer cars, if you look at the dashboards, typically it's very simple and exposes alerts, issues as they occur as quickly as possible, and then you can resolve them and take action across them. What we need is a monitoring system that does also the same thing. So the final sort of pillar of all of this framework is to ensure that you have a continuous monitoring and compliance in place, so that provides that feedback loop. Now, uh, this particular capability, as I said, needs to look across your entire stack, right? You have your application data. I talked about code. You have code. You have your network virtualization. So you need to be able to make sure that you can gather as much insight and data and logs from all of it, and feed into a centralized engine. So you should have centralized logging, centralized metrics, your access and audit trails. They need to be centralized as well. Even the vulnerability management solution that I talked about, they should all be feeding all of this into a central place. So then you can then create or generate insights that you can act upon, and then create dashboards, alerts from them, essentially. And and that's where the continuous compliance and monitoring solution should be geared towards. Now, obviously, there is some sample tools. You have SIEM-based applications like Splunk. ELK also provides a SIEM. AWS provides various offerings in there. They have CloudWatch, CloudTrail as well that you can integrate into their security hub. Azure's got Azure Security Center and Sentinel. And then obviously all the cloud providers have some sort of capability that allows you to aggregate your logs and system metrics and access logs and trails, and then generate insights from them, and then monitor from them. Now, just having a monitoring capability isn't sufficient. What happens a lot of times is people ignore the response to it, right? If something happens, you should obviously have some sort of predefined process to resolve those incidents. So if a security incident, I think people are typically good at operational incidents. So being able to handle when an application goes down, you typically have a run book that you follow, and resolve that incident or troubleshoot that incident resolve. But I think a lot of times security incidents are not always thought through, and the processes are not built. And this isn't a one-time thing. You have to build something and you have to continue improving that. So um, just having a monitoring solution is not sufficient. You need to also ensure that the process behind responding to those incidents, performing forensic analysis, is also thought through and also well documented and also improved upon constantly. um, One aspect that is also equally important, and it's not directly security related, but equally important, is the fact that you should have disaster recovery and continuity plans in place. I mean, today's world, I think a lot of companies have had to initiate their business continuity plans. So you never know when they might be handy. They could be for a non-security reason like COVID-19, but they can also be for a security reason as well. As part of data breach, you may have to initiate some of these. So being ready for it is also a key part of your ensuring your security posture across the space.
Also,
So I've rattled through a lot of details. I'm just going to summarize this before I move on, and just provide a few more details about how you can leverage some of these capabilities from the cloud provider. So to begin with, we talked about code, build, and deploy. And here, specifically, I think aside from the basic automated continuous integration deployment capability, you should look at things like peer review, instituting peer reviews, signing the commits and artifacts that you generate to ensure the authenticity of those, but also performing static analysis and dynamic analysis as part of the code and build deploy process. We then looked at a strong identity foundation, which was obviously things like single sign-on and list privileges, but at the same time, applying techniques that are also available like multi-factor authentication wherever appropriate, especially for any privileged access. And then also rotating credentials and generating short-lived credentials is also equally an important part of a strong identity foundation. We then looked at traffic, and traffic was broken into multiple aspects. There was the transport level security, but also we looked at, I discussed use of firewalls, layer 3 and layer 7, wherever appropriate, but also start to look at technologies like service mesh to then apply the same zero trust principles across your applications, especially because the application, traditional modern architecture is much more complex and much more scale than you have probably hundreds and thousands of applications running on cloud. Within vulnerability management, we looked at the fact that you should be automating updates and patches, but also isolating your security runtime and processes, and also identifying any misconfigurations and vulnerabilities as they occur and resolve them as quickly as possible. Under data security, there was, I talked about encryption at rest, encryption in transit, as well as field level encryption. I think that's an important consideration when you have any sensitive data that you want to protect. And then lastly, when it comes to monitoring and compliance, aggregate all your logs and metrics that you generate, as well as vulnerability alerts and vulnerability security alerts that come from various directions. You need to centralize them and then ensure that you have a process to respond to any alerts that come out of it once you've aggregated and generated dashboards and alerts from them. So that's the sort of the frame of applying zero trust in the cloud space. Now, it might sound like a lot, right? It is definitely a lot of things to consider, a lot of things to think about, and constantly as you're building software. And I'm sure some of you might feel who are probably new to cloud or have not adopted cloud to the extent some others have. You might just feel scared. But my intent wasn't really to scare you. I just wanted people. I want people to be aware of the possibilities and why they should be doing certain things. In fact, a lot of these capabilities that I talked about are already available out of the box. I mean, this picture shows the same controls or the same framework and applies some of the AWS capabilities that are already available that you can leverage at various levels. So, for example, in the code and build and deploy, I haven't mentioned the AWS out of the box capabilities, but AWS has AWS Code, AWS Build Pipelines, and various other capabilities. And then you can supplement it with open source alternatives as well as licensed software. You can use SonarQube, Veracode, Artifactory, X-Ray, and many other tools that are available. With respect to Identity Foundation, AWS provides a good single sign-on solution, and AWS IAM. They also have Secret Manager. You can also use Vault, as I said, for the application-to-application certificate generation and visual TLS, authentication, and defining policies. And then so on, like with traffic, you have AWS Shield, WAF, which are our network controls. There's the app mesh that it comes with, and up to the monitoring level, right? So within monitoring, for example, you have the security hub that allows you to centralize all the insights from config coming in from their config rules, which is a compliance sort of an engine, or from guard duty, CloudWatch, CloudTrails. All of these can be aggregated easily and integrated. And if you wanted to, you could still use things like Elk and Splunk and supplement with other tools as well. The message basically is simple. A lot of these capabilities are available. All it requires is for you to be conscious and ensure that you integrate them, because obviously the fact that it's there doesn't mean it's there. It's already integrated with your application. So when you're deploying your next application, you need to ensure that you're looking at all of these capabilities and tying them together. A lot of times it's as simple as writing a Terraform resource or using a CloudFormation template that has those controls in there. But unless you're mindful and you're conscious, you'll not be integrating them, because out of the box it just doesn't enable that feature for you. Again, so there is a similar picture I've created, and Azure has a similar set of capabilities. They all offer capabilities in each of these spaces. So don't worry, do not worry. My intent wasn't to scare anyone. It's almost as if I want you to be aware when you're going in with your next cloud implementation. Ensure that you look at all of these facets and build those controls that are available mostly out of the box. Finally, what I want to summarize for you is I didn't mean to say that you shouldn't trust anyone, right? I mean, I'm not Robert De Niro from Meet the Parents who says you shouldn't be trusting people. But people do make mistakes. Mistakes happen. The misconfiguration with capital one, a legitimate case that can happen with anyone, or happens with everyone, and it's happening right now. Or for that matter, Maria did a data breach. I mean, all of these, they are accidental issues. A lot of times people just trying to do the right thing, but probably were either unaware or did something that they didn't know about, or they were not aware that what they were doing or decisions they made could have such an impact. And so we are all humans and we can all make mistakes, and failure in today's world is inevitable. But what is important is to be ready for failure. And the only way you can do that is by building your applications with zero trust. And that's all I wanted you to take away from this message. With that, I'd like to thank you all for joining this session. If you want to follow me, obviously there's links on here to my LinkedIn page, as well as the blog I usually write, and I write a lot about engineering and security, as well as site reliability engineering and other areas that I'm working on. You can follow me there. But also, if you guys have any questions, I'm happy to take them now.
Yeah, I'm opening up the mic, and obviously would like to hear from people um, if they have any questions or any specific thing that they need to ask with Mahesh.
Yeah, hi Mahesh. This is Dheeraj Singh here. How are you doing?
I'm good. Thanks, Dheeraj.
Hey, Mahesh, I probably will be a very basic question though, because I've recently got introduced with this the application side, because one of the projects I'm handling right now is building a homegrown application for the nursing home. So I was just wondering, um, you know, you know, in a short description, if you could, tell us about the current most critical and the current threats offering the internet application, accessing application side of it. If you could just throw some light on it, like the most current threats which we are looking at.
Yeah, sure. I mean, I can take I guess I'll attempt to answer that. Obviously, it's not holistic. But I mean, that is depending. I think that answer, it's a bit difficult to answer that question, but depending on the industry, things are changing, and things would change, and what sort of threat actors are interested, and all would probably change with that. I'm not a security expert, obviously, myself. I'm more a infrastructure engineering who has a lot of interest in security, and I've done a lot of implementations at the space. But I
Mhm,
think currently, obviously, I mean, the basics of phishing attacks through to, as I said, the whole abuse of identity credentials, the default credentials. I think those are some of the basic things that happen everywhere. And I believe in today's, I think there are quite a few threat actors that are quite active, especially in today's world. I mean, honestly, I think a lot of us are probably, there are many organizations and there's a lot of research out there, and people, companies that have published some of this material as well. But there's also people abusing the fact that a lot of people are a bit vulnerable. So with the COVID-19 crisis, obviously, people are abusing, and there are some fake messages also being sent out that are people sort of that allow, I mean, asking for money and asking them to sign up for things that they shouldn't be, and things like that. So I think, yeah, I mean, there's various things that are happening depending on the industry and the location you are at, probably. Um,
Yeah,
yeah.
it's the healthcare industry, and although I've been following all the HIPAA compliance and all HL7 and everything, I'm trying to accumulate everything utilizing the Amazon and all, but I just thought, which is fine. I think eventually it boils down to the data, which is the most important thing, I guess. Uh, anyway, yeah, I it's fine. Thank you. I got it.
Yeah, so a
So
couple of questions from people. I think Atul, you were asking something. Let me open the chat window, or you can. Yeah. So, uh, so what are the impact of error handling vulnerability to the infrastructure? Any input or links regarding security or trust around IoT, internet of Things connected device. So this is Atul asking. So any input or links regarding security or trust around IoT Internet of Things connected devices? Uh, yeah, Mahesh, we're not able to hear. Now you can.
Hello, can you hear
Yeah,
me?
yeah, yes,
Yeah.
yes, yeah.
Somehow I was on mute. Yeah, okay. Yeah, I was just saying, yeah, IoT is not an area I have worked a lot on, but I know that, I mean, I have some of my colleagues who work in that space, and I think it boils down to the same sort of basic principles that I said earlier, right? Securing the identity is critical, and then and then using secure traffic communication to your server side, essentially. So some of those things, I think, principles are still the same. It's just a different level. But I haven't specifically worked in the IoT space as such, so I'm not really aware. If I find out anything, I mean, obviously, I'll share that later on, or I'll follow with my clients as well. And then I'm sure there might be someone on this meetup who have worked in that space as well, who can
Yeah. So
figure out how these principles apply to IoT. Yeah.
yeah. So
Mahesh,
yeah.
Mahesh, can I have a question? My name is Umesh. So your slide is wonderfully done when it comes to defense in depth. But can you take me to the slide where exactly it shows the zero trust and all that? Because zero trust architecture is something which I understand is a mainly infra side.
So zero trust started more as a network thing. It originated
Yes, Forrester
from
Forrester has
Google.
started it.
Yeah, Google's proxy, right? They use that as a principle. What I have talked about is not necessarily just the network principles. What this talk was mostly about is specifically applying zero trust in everything you do, right? So when you're building an application, because I personally don't think it's not just the network, and also, I mean, the Google's zero trust approach also looks at authentication as well. So there's no single slide I would say that I can talk about and say this is zero trust, at least in my talk. Yeah.
Is this slide available for all participants?
Uh,
On
so
what?
slide.
Sorry.
So slide is not available. What we'll do is ideally we share the video on platform. So the recorded video which is there obviously will be available.
Sure. So to me, the zero trust architecture concept is basically a kind of agent concept which takes care of your user, device, and application. And then we create a joint score, just like we have a Siebel score. Based on that threshold, the further permissions are given for access.
Hmm.
The combination. For
Yeah.
example, suppose a website is only or a code repository is only accessible using say desktop. So you have taken the MAC address of that desktop, then you have the user
Yeah.
credential, and then the moment the person is trying to approach the same repository via say mobile
Yeah.
phone, now that combination doesn't get validated, and hence the permission is not given. So that
Yeah.
concept is moreover comes in the direction of zero trust architecture. I was
That.
looking something from the application side in your the slide when I uh, saw this subject actually.
So yeah, that's true. As I said, right. So if you look at the zero trust security principles from Google, that's exactly what they have, right? So the whole idea being that it's not just where you are that matters, but so for example, if I access the company's corporate website from France, and then 2 seconds later, if there's a request from India with the same credentials,
Right.
your trust drops, and they build a trust score. Yeah, that's so that is again Google's zero trust approach. This my talk was more a broader talk about looking at zero trust in everything you do, right? So when you're coding as well as apply principles of zero trust, such that you don't trust either the libraries you're using or the software you're building. So it's not all. I think the focus of my talk was a bit broader than just that scenario of that the Google zero trust principles use essentially. Is a different.
Right.
Yeah,
Obviously,
and
Right.
I'm not saying that one is right or wrong. Yeah, that is
yeah,
definitely an area. and you can do more research in that. Yeah.
Yeah, and adding to Mahesh, when I started, if you remember, I believe, I'm not sure Mahesh if you joined from the beginning. We talked about a house and why in the house, if someone enters, you need to understand who is going to enter into your house. So anyone who is going to enter into your house need to be understood, need to be acknowledged by the family, or at least any one of the family members should endorse, and there must be a trust between the person who is entering and the person who is inside. And that's why here, when we talked about zero trust, or when we're discussing about zero trust, we're taking a holistic approach. It's not just network, it's not just a couple of devices or the application that we are working on. It's in a holistic term of how that concept can be elaborated, extended to each and every touch point, every system that as an actor, either it's a human actor or a machine actor, which interact between each other. When it interact between each other, there must be a trust between them, and that's where I think Mahesh's concept has come up, to be a little holistic around the thought, not just the concept as zero trust that started from the Google and talks around the infrastructure, but how it can be utilized in a bigger picture.
Right, right, right. I got to know, and then I would again. I have missed, I think, initial 3 4 slide because of my audio was a little
Yeah,
problem.
so we restream
And
it. Yeah, no issues. We restream it, and we post it on our different channels. So obviously, if you are connected through one of our channel, you will get that out definitely, or you will have to go into multicloudforyou.com/evangelism, and you will be able to see anytime, like after half an hour, 1 hour, once it get published.
great. Thank
Or
you
you
very
can
much. Thank
go to our Facebook page. It's already streaming. So one that streams out, it get recorded there. So anytime you can replay it. So on our Facebook page, if you go, you will be able to see
you.
multi-cloud for you. Yeah. So another question
All right.
was, yeah. So thanks. It was really nice interacting. And another question is, uh, so what is the impact of error handling vulnerability to the infrastructure? Impact of error handling vulnerability to the infrastructure, Mahesh. This is from Root. Hi, Root.
Yeah. Root. Yeah. Do you want to elaborate that? I guess I'm not sure when you mean by error handling vulnerabilities.
So yeah, Root, if you can, I can open a mic for you. Okay. So once he comes back, Um, so IoT, we have already, like Mahesh has answered. So adding to that, obviously the edge devices which are there, and the edge solution which has been provided in the cloud, um, is a major point where the whole framework is being developed, and the whole security framework is being parameterized, and that whatever the edge devices is there in your home, in your perimeter, from where all your locally connected IoT devices are connected, the edge should be secured. Once the edge should be secure, obviously the devices will also get secure. But obviously at the device layer and the level, security is required, and that security is gone by the principle that you apply there in terms of token and refreshing the token, as Mahesh said, whenever it does a call to the either the edge server or to the cloud directly. The another question is, and COTS based product generally don't allow to touch TV, like you mentioned about encryption or data at rest. Gajinder Rathor. How data loss is handled? Any tool is available?
So I think, yeah, the COTS one is pretty interesting. Yeah, I don't not necessarily have a solution to that, but I guess it depends on the COTS product that you're using. They may or may not allow you to encrypt at rest from an using external keys and stuff. But I would suggest they say if it is a COTS product, depending on the type of COTS product, but let's say it's a content management system, e-commerce system. If they don't offer any encryption at rest or encryption of columns, then you probably that is an area where you should look to customize if needed. So, for example, if you had the example of the payment form where you're accepting any payment data or PII data, maybe that should be stored separately from the COTS product itself, so that you can apply the same principles that you would apply typically in an application. So store it in a separate database, which will then allow you to apply the same controls.
Yeah, I think that would be great idea. So instead of like if it's not there, then you may have to encrypt it on your own, and obviously
Yeah.
using asymmetric key is the most important thing. So now
Yeah.
no more people are no more using the symmetry key concept. So obviously public and private key pairs should be there, and the most important thing is either you trust the cloud provider. They provide now the key service which can be used on your even on your local machine or browser to encrypt the data and then send it back. Or if you don't trust them completely, then you can use your own vault and then
Yeah.
use it. So
Yeah. And
how?
there's a
Yeah,
concept.
yeah,
Sorry, I was just saying there's
yeah,
also concepts of encryption as service where you can send a payload and get it encrypted and then store as well. So again, there
yeah.
is various solutions to consider as part of that implementation.
Yeah, and when you're sending the payload, obviously it's a TLS3, as I said, as Matt said, is obviously encrypted if you are applying TLS 1.3, 1.2 or something. And then another question is, I mean the error handling vulnerability where web app throws error when credentials are wrong while login. What if from that error handling attacker tries to get into web server and through that he could get into? Yeah, obviously that's a software uh, based concern. That's why there is a vulnerability check, right? Mahesh, I think you can answer that.
Yeah,
So
yeah. So typically, the way that has handled, I think, is you also need to scrape the. So before you log something, I know that I think in Log4j, actually this is probably possible where you introduce certain code which will ensure that you it filters out any or hashes or changes the passwords or anything secure. So it'll look for some patterns and it will remove them before they get into the system. And having said that, there is still a possibility they can get leaked and can happen. I mean, I think the classic case was with Monzo, probably is where they had some passwords in their or debit card pins or something like that in their logs. And the only way to solve, I mean, if that happened, and when you find out that it happened, you should have the ability to sort of restore that or resolve that as quickly as possible. I think in their situation, they changed the debit card pins for everyone or expired all their pins within days, and then everyone had to go to or use a new pin, or you go and reset that pin or something. So there are some frameworks that you can use, but nothing is foolproof, and you might still, as I said, have an incident where a password gets into the logs, and then the only way to solve that is have an appropriate incident process to resolve that.
and adding to logs, obviously in the when the website sends you the error, so that's why Mahesh has said now people are insisting on centralized logging. So adding to log, people are insisting on centralized logging. So all the data that gets sent back is sent back to a centralized logging place, and so you don't need to throw it directly to the application interface or your touch point. So touch point is obviously, and obviously that's why there is a vulnerability check that happens, and there is a separate team in most of the IT provider or a software company, or if you work with bank. So they check that what are the messages. There should be just generic message that comes out when you just prompt them, like when the user is not able to log in correctly. So maybe
And I guess the
login
one
not done or something like that. Yeah.
Yeah, maybe there was one thing point that wasn't clear, that is you should never be logging credentials as part of your logs, by the way. You should always you should obfuscate or remove the data or hash it or something. So never log the credential itself. That's not a best practice.
Yeah.
There was a data loss question. I think that's an interesting one. There is no, I mean, I think it's more about recovery and backups. So obviously, AWS provides out of the box backup capabilities that you can take backups of volumes and various databases and stuff like that. So similarly to Azure as well, and many others. So the best thing to do is try and use as much as possible native capabilities, but there is also products out there in the market that allow you to that you can use from the marketplace as well, if in addition. But most of the time, I'm seeing the native capability that is offered is good enough. But the only thing you have to do is make sure, if you are in running in one region, you need to make sure that your backups are taken and snapshots are stored in another region, and you have some sort of automated capability to recover them on a periodic basis, and most likely automated, and restore and just test the services coming up with the backups.
Yeah. So similarly, there's one question, last question from Jay, and then we'll drop up. He's saying, what are the minimum security layer and must-have security setting we should consider for a small application? So yeah.
Yeah,
Yeah.
that's a very, I think
Yeah.
that's a great question, and it's hard.
Big
I know
question.
it's yeah. I would say the basic principles of, I mean, no matter how small, identity, you always have to transport level security. I think that is bare minimum that always should exist. You should always ensure that there is identity, transport level security and identity is bare minimum, and you should do that. Now, some of the other controls, I guess, like when the few things that I talked about around monitoring, vulnerability management, the whole CI/CD pipeline. I think a lot of them are they are required, but I think you should evaluate how much of that is really required for the use case you have. Again, as I said, there is obviously there's I think you should apply. There's a bit more of a security evaluation that should typically happen for most of the applications, so you understand the actual threats, you do the threat modeling, and understand what sort of controls you really need based on the data confidentiality of the application and various other factors before you actually implement all of it. But having said that, I mean, honestly, I think a lot of these, since they're just out, anything that's out of the box available from the cloud provider, you should just leverage, try and use it. So if it be data encryption at rest, data encryption in transit, or applying controls, basic controls and compliance policies and vulnerability management, and they just come out of the box. So if you're using native, I would recommend as much as possible try and apply the framework as if possible.
Yeah, and adding to that, everything happens gradually. So if you will not be able to do everything for a small organization, or maybe you're starting new and you understand, or everyone understand in the organization that whether the thing that they're going to secure is 5 rupees note or a box of a 5 million rupees or $5 million box. So obviously,
Yeah,
it's like it's software also. The value and probability grows with the time, or sometime you feel that no, the value is is a diamond from the beginning. So based on the whatever you possess and what how you feel that how big you possess, you will have to secure it in the same manner, or you can gradually secure it, but you at least set up the foundation which actually grows up seamlessly, and eventually it
correct.
secures you correctly. Yeah. So thank
Yeah,
you everybody. Yeah. Yeah.
there's
Yeah.
an aspect of continuous improvement there. Yeah.
Yeah. Yeah. Yeah. Yeah.
Cool.
Yeah.
Right.
Okay, so thanks everybody, and thank you Mahesh for like giving us time and to the forum, and it was really engaging, interesting, and a lot of learning happened today. And thank you everyone who joined and who are there on the streams on different channel. And obviously we'll send this and share this session soon on multi-cloud for your YouTube channel, Facebook page. Obviously, it will auto recorded and on different websites and groups that we have. Thank you, everybody.
Thanks a lot, guys. Bye. Thank you, Jenny.
Bye.